Everyone's talking about AI agents, RAG, and multi-agent systems, but most explanations skip the fundamentals. Today, I'm going to take you from zero to actually understanding how all of this works and how each piece connects. Here's what we'll cover: machine learning basics, deep learning and neural networks, large language models, RAG or Retrieval Augmented Generation, AI agents, and multi-agent systems. Each one builds on the last. Let's start at the beginning. Machine learning is simple. Instead of writing rules, you give a computer examples and let it figure out the patterns. Traditional programming says if price is greater than 100 and reviews are above 4, recommend. Machine learning says here's 10,000 purchases, figure out what leads to a buy. There are three main types of machine learning. Supervised, where you label the training data. This email is spam, this one isn't. Unsupervised, where there are no labels and the model finds structure on its own. And reinforcement learning, where the model learns by trial and error, like playing a game until it wins. Deep learning uses neural networks, layers of simple math functions inspired by how neurons work. Instead of processing data sequentially, each layer extracts higher-level features and passes them forward. Input goes in, patterns come out. Here's how neural networks actually see. Layer 1 detects edges and lines. Layer 2 combines those into shapes and textures. Layer 3 recognizes parts like eyes or wheels. And Layer 4 identifies full objects. Each layer builds on the last, from simple to complex. In 2017, Google published Attention is All You Need. The transformer architecture changed everything. Before this, models processed words one by one, which was slow and forgot early context. Transformers can look at all words simultaneously and learn which ones matter most to each other. An LLM is trained on the internet. Books, code, conversations, trillions of words. Its job? Predict the next word. The cat sat on the mat. Do this billions of times with billions of parameters across thousands of GPUs, and something surprising emerges: reasoning, creativity, understanding. But LLMs have a critical flaw. They only know what they were trained on. Ask about yesterday's news, they don't know. Ask them to summarize your company docs, they can't see them. This knowledge cutoff problem is where RAG comes in. RAG stands for Retrieval Augmented Generation. It fixes the knowledge problem. Instead of relying only on training data, we retrieve relevant documents at query time and feed them to the LLM. The flow: user asks a question, system searches a knowledge base, top results are retrieved. LLM gets both the question and the context and generates a grounded answer. RAG gives you up-to-date information, no more knowledge cutoffs. Company-specific knowledge from your internal docs and databases. Reduced hallucinations because answers are grounded in actual documents. And citable sources showing where the information came from. It's how ChatGPT with search works. It's how Perplexity works. It's how enterprise copilots work. RAG is powerful but passive. It answers questions. It doesn't take action. For that, we need agents. An AI agent is an LLM that can take actions. It has access to tools, web search, code execution, APIs, databases, file systems, email, and it decides when and how to use them. Agents run in a loop. First, receive the goal, then think, what do I need to do? Then act, use a tool, then observe what happened, then ask, am I done yet? If not, repeat. This loop continues until the task is complete. Coding agents like Claude Code and Cursor don't just suggest code, they read your entire repo, make changes across multiple files, run tests, and commit. Research agents search the web, read papers, synthesize findings, and write reports. Data agents query databases, generate charts, and send reports. DevOps agents monitor systems, diagnose issues, and apply fixes. But single agents hit limits. Context windows fill up. Complex tasks need different skills. One agent can't do everything well, and sequential processing is slow. Multi-agent systems solve this by dividing work across specialists. Fresh context per agent, the best model for each task. Parallel execution, think team, not solo worker. Common multi-agent patterns. Supervisor, one agent coordinates while others execute tasks. Pipeline, agents hand off in sequence, like research to writing to review. Debate, agents argue and refine ideas together. And swarm, agents self-organize around tasks dynamically. Picture a software team as agents. A product manager agent defines requirements. A developer agent writes the code. A reviewer agent catches bugs. A deployer agent ships it. Frameworks like AutoGen, Crew AI, LangGraph, and OpenAI Swarm make this possible today. Here's the complete picture. ML teaches machines from examples. Deep learning adds neural network layers for pattern extraction. LLMs use transformers at scale for language understanding. RAG adds real-time knowledge retrieval. Agents give LLMs tools and actions. And multi-agent systems create teams of specialists. We're moving from AI as a tool to AI as a team member to AI as an entire team. If this helped, subscribe for more deep dives into AI architecture and drop a comment below. What topics should I cover next?